Hi everyone, so today I'm going to discuss about how we can use applications of maximum and minimum for our day-to-day life problems. So first let's discuss about some two problems, then we can understand the idea. So this problem is given by some workforce on a company. So it is given that suppose that a new company begins production in 2015 with eight employees, and the growth of the company over the next 10 years is predicted by this given formula. So where n is the number of employees and t is years after 2010. So determine in what year the number of employees will be maximized and the maximum number of employees. So we know if we ask to find the maximum or minimum, then we need to take the first derivative and then we need to set it equal to 0. So here we have to use the quotient rule because it is the ratio between two values. We have done it here, and after that we have set it equal to 0, and we can obtain these are the two values of our critical values. T is equal to positive 4 or t is equal to negative 4. So we know time can be a negative value, so this is the only possible value. So then by using a sign of the derivative, we can confirm that this is a relative maximum. So now we know when it becomes after 4 years this function become maximum. So it is 2010 plus 4, so it is 2014. So in 2014 number of employees in this company become maximum, then after that it is decreasing. So in such a cases, the behavior of number of employees or behavior of the cost or anything we can analyze by using this maximum and minimum. Okay, now let's go to another problem. And so this is basically on minimizing a cost. So in this problem it is given that a farmer needs to enclose a rectangular pasture containing this amount of square feet. Suppose that along the road adjoining his property he wants to use a more expensive fence, and that he needs to no fence on one side perpendicular to the road because a river bounds his property on that side. In the fence cost $15 per foot along the road and $10 per foot along the two remaining sides that must be fenced. So what dimensions of this rectangular field will minimize its cost? So this is the total area and these are the cost for each foot of length. So I think we can't draw any get any picture about this idea. So first we draw some picture about using this given story. So this is the road and this is the river. So it is given that x represent the length of the pasture along the road and y represent the width. So now we can write an expression for the cost function. So for here it is $15 per each foot. So total length is x, so 15 times x, and for here it is 10 times y, and for here it is 10 times x. So totally it becomes 25 times x plus 10 times y. But this expression is with two variables, so we can convert it into one variable expression by using the given second information. It is given that total area is this amount, so x times y is equal to total area and it is this amount. So we can isolate y and then substitute for this given formula. Finally we can obtain an expression for c with one variable. Okay, now we need to find the maximum or minimum, then find the first derivative. After that set it equal to 0, then we can obtain our critical points are positive or negative 800. So length can be a negative value, so we can take only positive 800. Now by using the second derivative test we can confirm that our second derivative is positive, because if you plug 800 for this one it becomes a positive value. So at 800 it is a minimum. So our cost become minimum when length is equal to 800, and then we can calculate our width by dividing this amount by 800, so it is 2000 feet. So okay, thank you everyone, and let's